Okay friends, welcome. So we have discussed till now what stats, how to import the data, how to process some data, what are data types. Now we will go to some bigger thing called plots. Plotting is very important in data to visualize things and to describe things, though we will talk more about description later. What sort of description is required and those sort of things. So let's now first go to R keyword. So as earlier, we will import the data, import our file. Now as you see, the file is there. There is a plot tab completely, and as I told you earlier, when you install RK teaching package, complete teaching tools come here. So there is no problem, either you use this or you use this, that is not a problem. However, the teaching one is subset of the plot one. This is much bigger, this includes multiple things. Okay. Now let's go for the charts. Okay. So first of all, let's go for a histogram. Before we go to a histogram, we need to understand what a histogram is. Okay, and I will demonstrate that with the help. So again, we will take our same variable JP01. Okay, histogram option, cumulative frequency, relative frequency. There is not much difference. We will go for relative frequency. Okay, and we will submit. Let's see what happens. Yeah. So now as you can see, this is not an error, this is our understanding, and we will rectify this. So this is talking in the interval of 0.5, 0.5, 0.5, 0.5. So our data is like this. Most of the data is from between 4.0 to 4.5. Okay, and let it do it again, so that our okay. You can choose any color, that is up to you. Now when you choose cumulative frequency, there will be a slight difference, I will tell you that. Okay. I will now just see. When you take cumulative frequency, because the frequency will keep on adding, okay, it will keep on changing. Okay, so a cumulative frequency differs from relative frequency. Now what does frequency means? Okay, you see relative frequencies. So let's plot it again to demonstrate more about this. Histogram. Let's try this one. Both will work, that's not a problem. Histogram JP01. Okay, generic plot option. You can change the axis, you can change the grid. Let's add axis to the grid, everything we can do. We close here and we have histogram option. We have frequency bar labels. Okay. So both are very similar, that's a little difference. So as you can see here, so this is 0.2 out of the majority is density, as we again saw, is here in JP01 around 4. Again let's do it. See, so now this is again is a very demonstrative thing. from 1.5 to 2.5 all data is coming. Now we have around 590 frequencies, 590 data values, as you know we have talked about dimension. Okay, now we have around 300 plus values between 3.5 to 4.5. Okay, and again, though we do not have any value before more than 5.5, but the range we have designed is such that we are taking 4.5 as an interval to 5.5 as a closing interval, and whatever values come in between. So for that reason we are getting this graph. Okay, now the point you have to understand that this is a frequency distribution which talks about how much time a particular element. In our case, JP01 can take 5 values, 1, 2, 3, 4, 5. 1 is very less in this case. So how much time relatively 2, 3, 4, 5 has appeared? That is what does the histograms tell us. So please understand, histogram is a very basic plot. Okay, now there are multiple commands which you might say how to run histogram, and as you can see, hist my say data. So we will not go in that, but if you are more interested in typing it out yourself. Now the most important thing is how to import this image. So you can save this image at some place, okay, in some name, and we can deal about that. So this is possible. So play with histogram. Now other plots which we could try. Most of us know multiple plots. So let's put pie chart, and again let's take our JP01. Relative frequency. So again this is like a histogram but arranged in a circular fashion. So again you can see the color blue is most, okay, 1 is very less, it's same thing. Okay, so we have this pie chart. Now coming back again, the other charts, let's try scatter plot. Now for scatter plot you need 2 variables, so we will have an understanding that what is dependent on what. So y variable and x variable. I will talk about more little bit of this, that what's a scatter plot. Let's assume right now there is something called y axis and there is something called x axis. Okay. Now these are different models, we will talk about this later. This is quite advanced, we will talk more about in regression. Okay, and we will just submit it. So what is showing is, if you take combination of GOMO10 and JP01, different combination of numbers are possible. One is 5, another is 5, and one is 2, another is 5, and this way there are multiple combination. The scatter plot comes like this. Okay, now here is what we have to understand. What is a plot? What is a Cartesian plot? Till now we just drew histogram in which there was one axis below the graphs, what we call an x axis. Okay, so this is generally called the y axis, not in the pie chart. This is called the y axis and this is called the x axis. Okay, so please understand this. Again I will draw somewhere in the paint. So we have y axis here and x axis here. This means, now please understand, this means, and we are trying to say something, y depends on x. This means that y depends on x. Though we will talk about causality and association, if you remember our first slide where we discussed y stats, so we said summarizing is one part and causation, association and prediction are other part. But when we are drawing scatter plot, so which one has to be taken on y and which one has to be taken on x is a very important question. So generally which one we will take on y, we call it as a dependent variable. and x is independent variable. So, y and x. Now, please don't get lost right now. If you don't understand this, not a problem. I was just telling you what is a plot. Most of you might have known it in the 10th class, 12th class, you must have read it, equations. Okay. So, coming back. Now, there are other plots also. We will not talk about them a lot. One of this plot, I need to explain you what is a box plot. Now, what's a box plot? So, a box plot is something like this. Not always like this, you can always have modification. It tells you the complete data. The middle line of the box plot, this line, tells you the median. The lower quartile, what does a quartile is? The quartile is 25%. There are 4 quartiles. Quarter means 4. First quartile, second quartile, third quartile, fourth quartile. So, this data is first quartile, this is second quartile, this is third quartile, this is fourth quartile. So, median is the intersection of the first quartile, second quartile and the third quartile. Median separates the second and the third quartile. Okay. Now, let us check it, if we can get it something like this. Now, box plot tells us that how the data related, because this is quite interesting and more can be talked about box plot. Let us go here right now and show to you. Let us go to teaching, charts, box plot. Now, you can have box plot of multiple variables. Let us try 2 variables right now. Okay. Plot means points and color, you can choose anyone. You can choose blue. Let us submit. Okay. So, now as I told you, not all boxes are same. Here, this line is the median. Okay. Now, you will say why the box has not covered, because we have discussed something, done something here, this part. So, we will go ahead and we will look for box plot from this point. Okay. Horizontal, let us take these 2, only one is required. Box width is this, options, notch this, plot options. We are okay, we want this and we submit. So, no, we got a box plot, you see. Now, here is a horizontal box plot, not a problem. The main thing is there is an outlier, and you might say there is nothing called the third or the fourth quarter, because here we have only 4 values, 5 values, 1, 2, 3, 4, 5. Somebody rated 2, everybody else rated between 3 to 5. So, majority of data is lying on 5. So, the fourth quartile is very much on 5, that we have to understand. Okay. Editor, please use this diagram of box plot. Okay. So, please understand this is box plot, though other box plots are also possible. We are not going in detail. Now, what does it tell you? So, let us go in little more depth of this. Let us take some other variables. Let us take vertical, okay, plot options, grid, add grid to point, okay, submit. Now, here you see what is happening. GMO 16 and JP 07, we have taken 2 different variables. So, their median seems to be similar. However, the third quartile is stretched between 4 to 5. Okay. We can check it here, mean my dot CSV data JP 07. Just a second, my CSV. Okay, this is underscore. Yeah. So 3.9 is the value coming up. Okay. So now we should check how does JP07 look like. So we should again draw a histogram of JP07, just JP07, and just see what is happening. See here, okay. So the majority of data is between on around the 3.5 to 4.5, as we can see, then average 3.9, and most of the data 126 entry are between 4.5 to 5, which means they are particularly 5. So which is what is explaining here. The quartile is, the fourth quartile is getting extended here. So these are the things which we have to see in a box plot. It's very important to understand each and every variable. Now, depending on the number of variables you have, we have 180 variables here. You might not draw it, but if you have around 12 variables or 20 variables or even 5, 6, box plot helps you to understand, are there too many outliers? Like these are outliers here, 1, 1. So these are outliers. These are not part of the whiskers. You see, these are outliers. Whiskers means just extending to the lower limit or normal lower limit. Okay. So this is what we will understand much more when we understand measure of variability, that what is difference, how does the range affects the data. Okay. Now I think these plots will be enough for us for this time. Okay. There are other plots which you can explore, but they will not tell you much detail. Okay. Something like density chart is like a histogram, and I will show you that. Okay. So it's like an histogram, but it is continuous. So please understand, nothing much, but yeah, when your data is continuous, like I have 1, 2, 3, 4, 5, you can have 4.1, 4.2, 4.3, 4.5, 3.2, 3.3. Then it is density chart, which will help you to visualize data much better. But on the other hand side, histogram can also serve the purpose to understand, because here you see between 3.5 to 4.5, there is a, what we say, peak at 4. So now you understand, in histogram 3.5 and 4.5 is the same rectangle. You don't know whether data is lying towards 3.5 or 4.5 or in between. But in density you understand. So density is more useful when your data is much more narrow as compared to what we have. So we don't, for us, density chart for this data is not that useful as compared to histogram. Okay. I hope that will help you to understand things.